Hey everybody, Andrew here. I haven't used my ShapeOko3 for quite some time. I've decided to get it going. Previously I had lots of trouble with various niggling problems, especially things like the Z-axis plunging unexpectedly and just some random issues. Then I bought myself a 100-watt laser cutter, and that kind of occupied my time quite a bit. But you know, I've gone back to the ShapeOko. There's things you can't do with a laser. And I thought I'd just explain my crazy setup because it's a little non-standard. The first thing to note is I actually have my ShapeOko zeroing and homing to the front left. Don't know why, just decided to do that. I've got some stops that I made. Let me see if I can pivot around here. Some stops that I made that sit on the aluminium extrusion for the switches to home against, and that works pretty well for me. I have also I did a hack for putting a laser on here. That's before I got the 100-watt cutter, and that was very useful for marking horizontal and vertical X and Y reference lines, which I use quite a bit for aligning material. The other thing that I've got is I've made this sort of rudimentary fence just out of MDF that sort of sits on the wasteboard, and that's really good at catching sort of debris, as well as my socket that I got on Kickstarter. I've got the new one on order. I've also made a very rough cyclonic vacuum collector, so that collects all the debris and doesn't go into my vacuum cleaner at all. And then at the back here, you probably can't see it against the window too much, but I've got I modified things a little bit for cable management, and that works really well as well. So that's kind of my machine. I've also discovered some of the problems I had with the Z plunging. I suspected it was withdrawing too quickly, so I have changed the Z feed rate for like G0 rapid movements. I think that's 112. I've dropped that down to 3 millimeters per, it's not per second, whatever it is. I've dropped it right down to a third of the default value. The other thing that I found is when I had the hose, vacuum cleaner hose here, it was actually catching as the spindle was going up and down. The little rims and ridges of the vacuum cleaner hose was actually catching this, and I believe what was happening is it was catching, missing a beat. So I have, let me move the camera back. I've just made a very rudimentary holder for the front, so the hose now goes in and then comes out towards the front, keeping very clear of the spindle. So that's my machine. Now the other problem I had was figuring out how to use CNC. There is some good documentation in there, but like many, I probably don't read the documentation. I did look for some YouTube videos and didn't find too many that were covering sort of some of the questions I had. So that's kind of my plan. What I'm going to do next is I'm going to home the machine for you. I've got a touch plate. It's a 1mm piece of mild steel. I'll clip an alligator clip to the spindle, and that'll give me my my zero. I use the touch plate on top of the material, and then I'll show you how I do that. The other thing that I do is, and I've tried various things for holding material down. As you can see, I've got these rails and clamps. I actually don't like them. I find that the spindle or the bit ends up crashing into the clamps far too often. I can't position them kind of how I want, and if you've got very thick material, it just doesn't work with a clamp. So I found a very neat way of using duct tape. So what I will do is, not duct tape, masking tape. So what I will do is I'll put some masking tape down, just tear a piece off, just to give you a bit of an example. I'll put it down there. I can see my reference lines through there. I will put the piece of material down, but before I do that, I also put some tape on the material, like so. A much better job than I've just done there. I put the two pieces together and I hot glue it, and I just run a rim of hot glue all the way around the material, and it works brilliantly. If you give it a little bit of 2 or 3 minutes to set the hot glue. It holds it very, very firmly, and to get the piece of material off the wasteboard, it's just held down with masking tape, which it just comes off very, very easily. Obviously it doesn't have a huge amount of up and down or z-axis strength. You could in theory pull it off if you were milling something like aluminium, maybe. I don't know, I haven't tried that, but I've not had any problems whatsoever. So I will show you a full working example of how that works very shortly, but that is my setup. Have I missed anything? Let me read my notes. No. So what I'm going to do is show you how I use BCNC with working positions, which go to these various reference points on my wasteboard, using the touch plate, and things I've learnt that were catching me out and causing me problems. Okay, so I've got my piece of material here. I'm actually going to try and finish a job that previously failed, so wish me luck. What I've done is I've put some tape down where the material is going to sit on the board. I can see my etch lines through the tape. I'm going to center it or corner it on G58 as one of my working positions, so that's going to sit there like that. I've got the tape on there. Once it's positioned, I'll hot glue that down and we'll get started. Now, one of the other things I've been just starting to play around with is double-siding, or doing double-sided work. There's a number of methods for this, and I'm not saying this is by any means the best one, but it seems to work pretty well. There's a simple laser cut L. Once I've got my material aligned to where I want it, or essentially do that first, put the L where I want it. I would move the tape around so I can remove the material, leaving the L still staying in place. But once that is in place, I can then put my material against it. That provides a very nice reference point. I can butt it in against the L, and then once I've done one side, I flip it over, again butt it over, butt it into the L nice and neatly with more tape, and then just glue that in place and continue the milling. Worked pretty well the first time I tried it actually, and again I can just take it off very, very easy, no real problems. So while I'm waiting for the hot glue gun to warm up, one of the other problems I mentioned that I had was the Z plunging too deeply, and again the vacuum hose was catching on the spindle mount there, and a couple of occasions I actually had on longer jobs, had the spindle or the bit end mill coming loose, which was fun. The other one that I have found is a common problem, and if you don't notice it when you do the home, it can be a bit of a problem, is the Z-stops, the mechanical Z-stops are at the top of the movement of the ShapeOko. In your G-code, if at the beginning of the job it tries to withdraw so high that it hits those stops, it thinks it's gone to position, whatever, but actually it hasn't. It's the motor's skipped. It hasn't been able to do it because it's hit the stops. The consequence of that is, it thinks it's higher than it actually is, and when it goes down and the z-axis plunges down into the material, it goes way too low, and then you end up with a ruined job right at the beginning. So I'm very, very careful now, and certainly in my software, which I'm using Aspire now, making very sure that withdrawal rate off the material at the beginning of the job is only 5 to 10 millimeters. I think by default it was 20, which was causing a problem. So there we go. Let's glue this thing in and I'll be back. Okay, so I've got the material hot glued in, just a bead around the sides. One of the things I did notice with this piece is it was uneven, so it wouldn't sort of sit completely flat on the wasteboard. So actually the hot glue holds it in quite nicely. It's pretty secure, it's not going anywhere. So I've just roughly positioned the spindle over the area that I want to zero on. I've got the touch plate under there and the crocodile clip on the spindle collar. I'm going to hit the $C $H, I beg your pardon, and home it. Okay, so that is homed, and the touch plate was 1mm thick, and it has withdrawn 5mm, so that spindle is now, in theory, 6mm off the top of the material. What I'm going to do is move the camera now over to the laptop, because some of the settings and things that I've found with BCNC be good to share and tell others about what I found. Okay, back again. So I haven't done anything, it's homed, and again the machine is set up ready to go. So I'm using the working position. So we've got G, 54, 55, 56, 57. It was left on 57 when I homed. Basically what that's going to show me now in my working position is if I click the home button in this control area down here, if I hit the center button, the G button that's been pushed here, it will go to that place rapidly. Be very aware though that the W position along the top here, the machine's going to try and make those equal to 0. So one of the challenges I was having is when I was having trouble with Z position, is I was getting the bit crashing into the wasteboard and into the material and all sorts of things. So notice here that it's 0. That means if I hit the center button here in the control, it's going to go to G57, and the X and Y axis are going to move to make the positions in working position here 0. And it's already 0 in the Z, so nothing's going to move up and down. I am going to get some X and Y movement, so let's do that. And exactly as I expected. So you'll see now that the working position is set to 0. Now, one of the things I was doing is manually entering the working positions using the G10 L20 command. Under BCNC, once you've got a position in the machine that you want to set a working coordinate for, basically just hit X equals 0, Y equals 0, Z equals 0, and G57 has now been programmed in as a working position. Took me a while to figure that out. Also, you can set some temporary positions, which I'll show you shortly. So I've got mine set to G58 and the material set at G58. So if I click G58 button, you can see here in the working position, the X is not going to move, Y is going to move 50mm, and Z is not going to move. So if I click that button, perfect. So if you could see the machine, which you can't, the spindle is now right over that corner where I positioned the material on the wasteboard. So it's hot glued in place. The corner of the material is at G58 and it's ready to go. Now I'm just going to stop the camera and just make sure I'm doing the right things for you, and then we'll continue on and do the next step. Okay, welcome back. I was just checking a couple of things. So the material is in place. It's on reference G58, which is good. Now I have measured the center of the area that I want to cut, and it's trying to sort of fix a screw up from a previous job, so hopefully it works okay, should be entertaining. But I need to move the X and Y axis now based on those measurements. So I'm going to move the X47, type that into the command box, let's move that, and then Y100. Okay, so that's cool. Now if I hit x equals 0, y equals 0 in the top area here, that will override the workplace setting I have for G58, and I don't want to do that. So we set a temporary one, and this is one of the things took me a while to figure out, probably because I'm thick, but I do that by doing a G92 command for X and Y. And remember, when I zeroed off the material, the thickness of the touch plate was 1 millimeter, and it withdrew 5 millimeters as part of its movements. So it's actually 6 millimeters above the material right now. So I'm going to hit G92, X0, Y0, Z6. Hopefully that will give me a temporary workplace of 0, 0, 0 right in the middle of the material. So let's try that. Perfect. And now you can see the work position at the top here is 0 for X and Y and 6 for Z. And the good news is my workplace settings that I had previously set for G58 are unchanged. One of the problems I was doing is I was hitting the buttons here for zeroing X, Y and Z, and then wondering why my workplace settings were all screwed up and, again, crashing into material and causing all sorts of problems. So we're pretty much ready to go. So I'm going to set up the suction and the fence and everything else I need, and we'll come back. Okay, so the hose is in place. Everything has been zeroed. Material is secure. Hopefully the spindle's in tight enough. I will put my front piece on for my fencing. Just keeps any debris in place. It's going to get noisy, and it's going to cut where there's no material for a while, as it sort of catches up with where the job crashed last time. But I'll show you the end result soon. Okay, that took about 3 hours. You just have these blocks of wood in here just to make sure the socket actually has got some material on the same height to work against. And that looks pretty damn good. So just taking the material was pretty sturdy on there. It's cut well. My measurements were mostly right. So I'm just going to lift up the tape on the edges. There we go. So that tape now will just peel off the material. Just like that. There's no glue on the wood itself, it's just on the tape. And I've milled my object. So there we go, that's how I do it. Hopefully that's useful for somebody else, and there we go. Enjoy.